My name is Joseph Rowell. I'm currently studying my Master's in Robotics and Computation at UCL in my third semester. And the project that I'm working on for my Master's thesis is Semantic Validation in Structure from Motion. My supervisors are Professor Simon Julia and Ziwen Liu. This is a quick overview of what I'll be covering in this presentation. First of all, let me explain what structure from motion is. So structure from motion is the process of reconstructing 3D structures from constituent series of images to projections. And the input is a set of overlapping images of the same structure from different perspectives, outputting a 3D reconstruction of the structure. And the output includes reconstructed intrinsic and extrinsic camera parameters of all the inputted images. So structure from motion can be divided into three main steps. The first being feature detection and extraction from input images, frame by frame using an algorithm such as SIFT. That's scale invariant feature transform. In this diagram, it's detecting the corners. The second step would be feature matching and geometrical verification between the frames. That's matching those same corners between the frames. And the final step would be structure and motion reconstruction. So in this diagram, that's reconstructing the intrinsic and extrinsic camera parameters using bundle adjustment. Now, a problem often encountered in the feature matching step, where there is a scene with many repetitive features or a texturous scene, what can happen is erroneous feature matching. To illustrate the problem, this is Brunswick Square in Brighton, a dataset that I'm using. It's a square with buildings that all have very similar architecture and thus similar features. The dataset is about 20 minutes of 4K footage walking around the square, decomposed into raw images and downsampled for computational ease. This shows some of the repetitive features. So when I put this into Colmap, an open source structure from motion pipeline with over 1,000 images, the output shows that the feature matching algorithm has mapped both sides of the square onto the same side of the street. So shown here is a point cloud sparse reconstruction in Colmap. Each red square is the observation point optimized by bundle adjustment, and the points in the point cloud are the recognized features. Even with this being the first time you, the observer, has seen this environment, it's not difficult to infer the inherent spatial structure of the scene and object organization in physical space. And further that the model is not only wrong, but it's impossible. How can the observer see through this brick wall? It might be difficult to see in this picture. Here's a close-up of that same model at a different angle, showing how both sides of the street have been mapped onto one side, and there are observations behind a brick wall. We know this is impossible, but to the structure from motion pipeline, this model is fine. Now, what I'd like to do to validate or invalidate the model automatically in structure from motion is to incorporate the semantics in the image. I'd like to use the surrounding information to validate the model, such as a prior model constraint saying brick walls are opaque. To achieve this, first of all, I'm performing semantic segmentation on every input image using the TensorFlow model DeepLab v3+, performing object recognition with a pre-trained model. So using transfer learning on the cityscapes dataset. And so the pixels input to the structure from motion algorithm and the point cloud output have another dimension, which is their semantic label. And each semantic label can have its own constraint. So to begin with, we're just having a single constraint and we're specifying ourselves. Interesting possible further work would be to automate the constraints applied for each recognized object. So after object recognition, the object standard can be searched through something like ISO standards or CityDML standards, and the constraints applied accordingly. Another interesting route would be to apply this to Visual SLAM. This would require real-time reconstruction and mapping, something that isn't possible with this pipeline at the moment, but as this is novel research, we'll walk before we can run. Another interesting thing would be to incorporate it into the optimization in the structure from motion pipeline. So So it doesn't only invalidate or validate the model, but it actually corrects it. And I finished this project in September. I'm about halfway through. So thank you for listening.